How AYRA works. From the radiographic pictures obtained by computer axial tomography (CAT scan), and once the radiologist has established a diagnosis, it can be observed that there is a huge quantity of information in all the multiple cuts which can be used to describe the complex reality of this patient. There are several displays installed in AYRA, including one that allows us to watch the cinematographic sequence of the cross-sectional cuts, as it can be seen in this CAT scan showing a large tissue distortion that belongs to a patient who suffered a gunshot wound to the mid-face. We can scroll it up and down and visualize the multiple cuts of the CAT scan. We can see that the program has three different tabs in this menu. The middle one is where we can see the cut we have selected, and the right tab is where we can see all the cuts. We can attribute a green color to the pixels of the 2D cut we have selected. In this case, the ones that we selected correspond to the points of highest density, that is, the white colored tissues that correspond to the bone and the metal structure of the patient's table. After selecting a cut, we can see that the program applies the green color to all the pixels with the same characteristics in all the remaining multiple cuts. Here you can see AYRA's capacity to display what we just selected in a virtual way, entering parameters such as the perspective and, as we will show later, the textures. This is a tridimensional representation of all the multiple pixels that we had identified in green color according to their density. We have just showed you the bone reconstruction, and if we change the parameters in the menu, as it is being shown now, we can see that the density of the green pixels now corresponds to the soft tissue. This way, we can do a tridimensional representation of the soft tissues of the patient, as it will be shown in the following clip. Here we can observe the large facial soft tissue distortion, the multiple reconstructions, and the improved outcome. In every parameter that appears in this left menu, we can apply colors, textures, transparencies, in a way that we are able to see the spatial relationship between superficial and deep structures, as you can see now. Traveling inside the patient. We are now observing a patient who recently underwent facial tissue transplantation due to neurofibromatosis. More specifically because he had a plexiform neuroma in the bottom two-thirds of the face. The program allows us to travel through the body structures so that we can see in great detail all the spatial relationships between, for example, the vein and the bone structure. As you can see, each section is represented by multiple triangles which have the same spatial orientation as the ones obtained by the CAT scan. AYRA in the operating room. The transfer of these biomodels to the operating room can be done through this virtual model itself, which the surgeon has available at his disposal. And with a sterilized computer mouse, he is able to see in an augmented reality the surgery he is performing to the patient, in comparison to what he has planned in AYRA, in virtual reality.